Hello everyone, I'm Paul. I work for a company called Anaplan, and I doubt many people in this room who haven't worked for Anaplan know what Anaplan does, or why we exist. So Anaplan is a company that produces a platform for planning, in the name. And when I say planning, I mean all kinds of planning. We're talking about businesses that want to plan their finances for the next year, 10 years, 20 years, want to do their supply chain and work out what they're going to produce in what factories, when, want to working out what their headcounts are going to be. You know, are we going to need to hire more people to fulfill these roles, to do these things? What's that going to cost? How does that feed into our supply chain? How does that feed into our finances? And it allows you to really connect all of that business planning together. It's actually a pretty cool piece of software, but it's all kind of aimed at really big enterprise companies, which is why hardly anyone really knows about us unless you happen to be, you know, the CFO of one of the 2,000 biggest companies in the world. The technology stack we build on is kind of cool. There's a lot of Java going on in the back end. We run our own private cloud, and as it's a cloud-based platform, most people are accessing us through web browsers, so lots of JavaScript on the front end. But we've never done a mobile app before. And so about 9 or 10 months ago, I joined a team at Anaplan, starting that very first mobile app, and we decided to do it with React Native, which is maybe not a surprise given that I'm standing here. And we decided to do it with React Native for all the reason that you would expect. So being able to bring in those guys who are already doing our JavaScript front end in React and leverage some of the knowledge and expertise that they already have. Being able to hire, you know, a cross-functional team with which already has that React knowledge from the web and bring them into the native landscape, and not tying ourselves down to developing two code bases for two different platforms. You guys all know this, so I'm not going to labor it too much more. So that's who Anaplan are, and that's what I do. And this talk is about the hunt for the Scrolly Grail, grids in React Native. And I'm going to start off by saying what is a grid, because it's probably a useful thing to define. Here we've got an example of what might look like a worksheet in something like Excel. A table of some kind of content or of some kind of data, maybe formatted, maybe with some interesting information in. Sorry, I'm a nerd, that's why it's all board game related. And we want to be able to view this, you know, in a way that is good for humans to actually look through things. So the first thing I'm going to do is talk about a few assumptions about what we're going to really want here. So at some point there will be lots of data. And when I say lots of data, I mean not kind of terabytes and you know, billions of rows of data, but we're talking, you know, enough that a human needs to be able to comprehend it and be able to navigate around that and try and work out what's going on, and can't do that at a glance necessarily. I'm also going to assume that humans think in rows rather than columns. And what I mean by that is I'm assuming that I'm going to have more rows in this grid than I'm going to have columns. I'm making that assumption. It might not be true for everyone's use case. So just keep that in mind when you're thinking about the solutions that I'm presenting here. And I'm going to assume that we want to work in JavaScript because it's the best. So because of that, I'm just going to show you what the shape of the data that I'm going to be talking about in all of my examples is going to look like here. So we have the idea of a grid, which is going to be this array of data. We have rows, which are going to be objects. You'll notice that rows have IDs, and in this case, cells have IDs as well. That's me cheating because we need to put keys in React Native, and I'm making that easy for myself by just baking that into my data. So grid, array of rows, array of cells, which include the data that we want to display in our grid. And this is what some code that would just display a basic grid looks like. So we've got a nice view with another view with cells which are more views. It's just drawing boxes on the screen, right? It can't be that hard. And we can kind of see just illustrated there where those things lie on this phone rendering that with some test data. In this case, it's also useful for me to point out that the ABC and the numbers down the left-hand side are baked into my data in this case as well. So they're not separate to my data in this example. But, you know, that's a grid, a very small part of a grid that we can see there. And more than likely, we're going to have a grid of data which is huge. It's going to have way more data in. and we've got a small screen. We want to be able to navigate that data. And what if the thing that I want to look at is actually, somewhere off my screen? There's lots of ways in which we've tried to do this in the past. In the web in the 90s, you had paging on tables and things like that. Then we introduced the idea of filtering and searching so that you could control what was in that view. But with today's mobile phones and touch-sensitive devices, scrolling is really the natural way that people tend to interact with, this kind of data. And it's been, quite a move towards that. So how do we make that nice? What is our Scrolly Grail? Well, I'm going to straight up tell you now, sorry, there's no such thing. There is just a bunch of trade-offs. So really, this talk, I've lied to you all already. There is no Scrolly Grail, but we're going to talk about ways you can get close and hopefully achieve what you want to achieve. And in this case, what is my Scrolly Grail? Well, my Scrolly Grail is I want smooth scrolling on iOS and Android. Important to give a good user experience. Ability to fix columns and headers in place. And there's kind of a fourth one in there as well, which is the ability to scroll in two directions at once. And you'll see why that's the case. Just a really quick overview of some components. You're all probably doing React Native, so you're probably all aware of scroll views and flat lists. Scroll views, if the content is bigger than the view, it lets you scroll, but only in one direction at a time. So you can either set it to go horizontally or vertically. But it gives some nice things like you get bounce on iOS and you get momentum and things like that, which is all kind of cool. And flat lists, which is similar, but doesn't do something which a scroll view does, which in a scroll view, you give it the content, it's going to render all of that content, even if it's really far off screen. And if you've got 10,000 rows of data in your grid, you don't really want to render past row 50 probably. So this does some virtualization for you and has lots of convenient functions that help you out with that, etc., etc. And again, lets you scroll content when it's bigger than the view. All super useful, and we can use these to make a really basic scrolling grid that goes in horizontal and vertical scrolling. So very much like my earlier example, but this time we're just wrapping everything in a scroll view and a flat list and giving that the relative functions. This is a little GIF showing you what that looks like, and it does work great. Like it works really well. And if all you need is the ability to look through a bunch of data like that, great, you're done. You guys can leave. Well, stick around for the other talks. But more than likely, you want to do a bit more than that. So our Scrolly Grail, we said, was going to be fixed headers, fixed columns. Well, okay, let's start with the easy one, fixed header. Flat list gives us a prop where we can just stick some rows to the top of the grid, as it were. So easy peasy, we've got that row stuck to the top, and we've still got all the lovely things like a bit of bounce at the end there and all of our momentum and things like that. Fixing a column is a bit harder. We can't just do things like pinning the first cell in our row to the front of it because we've got a scroll view which we're inside, so we're just going to scroll past that. In which case you have to start doing all sorts of maths to offset where that cell is kind of absolutely positioned to be back inside the viewport. And it gets a bit horrible. So what we can do is actually, let's have another flat list. Let's put something next to our scroll view, which is going to contain those first cells, to stick them in place on one side. And that's great, but now we've got two separate flat lists. So when we scroll horizontally, oops, we chose poorly. So we can try and fix that by syncing the two columns together. Now, this doesn't come across great in this GIF, but you can see where there's a little bit of lag between the two as I go up and down with scrolling there. And that's because we're trying to say, when I scroll this one, if this is the one where the scroll event happened from, scroll that other one too. And fundamentally, we run into problems with sending commands down the native bridge and saying, do this and now do that. Well, as I say, we chose poorly. So let's have a quick conversation about the native bridge here. So, and there's Jeff Bridges to help me. Whoops. So how does, at a very high level, what is it doing? Well, when we communicate with native land to ask an actual, whatever the underlying scroll component is in iOS or Android, it's actually a command that's being sent over that bridge. It's not your code that's being run in that native land. Your code is generally being run on your JavaScript thread. of which there is one, and you don't really want to block that up. So we're sending at the moment a command, effectively the touch event is happening, one thing is scrolling, it's coming back up to us, we're then sending another command back down that bridge, Jeff Bridges, and it's telling the other one to scroll on there, and so you're always going to get that kind of off by a couple of frames render. Actually, you don't really notice it on iOS, weirdly. I'm not quite sure why. It's just better at not having that getting out of sync. Maybe it batches the commands more before it renders them. But for whatever reason, it's really obvious on Android, so kind of sticks that solution in the mud. And this is where Pan Responder comes to the rescue, in that we can wrap everything in this Pan Responder. And rather than responding to the touch events in our scroll view or in our flat list, we now delegate that up a level. And the Pan Responder can then tell both of those things to scroll at pretty much the same time. So you don't see that delay. You do have, in theory, a delay between the touch event happening then and the actual scrolling happening, but it is very minimal because modern phones are pretty fast, right? And it gives us another really good thing, which is that we can scroll in a horizontal direction. Because we're tracking scrolling with one component, and we're telling two different, or in this case, three different scrolling items to scroll. So we've got the two flat lists and the horizontal scroll view. We can tell them all to scroll at the same time. We can calculate the vector and go, okay, well, I actually need to scroll in a diagonal direction, which is really nice. So here's an example of some Pan Responder with some maths in it that we're doing. And an Android phone where you can see we're scrolling around in two directions at once. I'm not going to go through that code because I don't have time, but you will notice that this header at the top here kind of jumps up and down for some reason. I've tried to make it as obvious as I can. It's really annoying. I still have no idea, after working on this solution for quite a while, why that happened. So if anyone can tell me, that'd be great. It only happens on Android. Doesn't matter how new your Android device is, you see this happening when using this kind of solution to scroll those in and out. Android. What do we do about that? Well, we cheat a little. What we're going to do is put a fixed header over the top of that. So we're not going to render that sticky header. So we're going to ignore that solution that we had from the very beginning, and actually, render that ourselves at the top of our scroll view and glue it to the top, or more likely to the top of the view that's surrounding the scroll view, to keep it there. So it still has to be inside the scroll view, so that we can scroll it left and right, but when we scroll up and down, it's still stuck at the top. And that works pretty well. So on Android now, exactly the same code base, but with us rendering that header, it's quite nice. We've got that 2D scrolling, we've got our lovely column stuck to the left, we've got our header stuck to the top, but we've lost some things. And this is why I say there is no such thing as the Scrolly Grail, because we've now lost all the lovely momentum and bounce that we had for free from those components, because we're driving everything from this Pan Responder that's just giving us, this is where your touch started, this is where your touch ended. It does give us information about the velocity, so how fast you are making that gesture, which is super useful because it means that you can start implementing the momentum and the bounce and other things yourself, but you do have to do it yourself. And not only that, but you're going to be adding all that maths in to the point where someone is making that gesture and adding more time between someone making that gesture and you telling all three of these views to scroll. You don't necessarily want to add a huge amount of JavaScript logic there, but it can take quite a bit, and I can prove that because, well, I did it. So you can see here, this is the Anaplan mobile app as it stands at the moment. It's completely unreleased, but hopefully will be eventually. And you can see that we've got the ability to fling and have that momentum in there. And we also can do other fun things with this now. So you can see how that column on the left-hand side isn't fixed until we stop, at which point it comes back in. So you can do all sorts of other cool bits and pieces. And with this technique, you can pin more than one column and more than one row to the top and the side. Just to show that the Anaplan app isn't just some weird Excel ripoff, there's some other views of other things that it's going to display users, so the ability to filter through data and have interesting boards with key values for your executive to look at and go, why are we losing that much money? And so on and so forth. So that is where we're at with our grid at the moment. We're going to do some more cool stuff with it, hopefully. And I describe what I've talked to you about today as a pattern rather than something that I would produce as a library, because for each person, their trade-offs, or for each product, their trade-offs are going to be different. You don't necessarily want to follow this exact pattern, but hopefully it gives you an idea of a way of tackling this problem and of composing these components together purely in React Native, purely in JavaScript to do that. So obligatory we're hiring slide. Anaplan, I joined the London office when we were about 25 people. I think we're about 150 people now. That was less than 2 years ago. We are growing. We need more engineers. We want people who are interested in React and React Native. We are hiring for mobile engineers on a team. So if I haven't annoyed you too much and you would fancy working with me, check out careers.anaplan.com. Come and speak to me later. Grab some of the swag that's around and give us a shout. But as I said at the very beginning, we have a wide technology stack. There's Java, we do C#, we do a bunch of Kotlin at the moment as well, lots of JavaScript on the web as well. If any of these things appeal to you, please give us a shout. A couple more bits and pieces quickly before I try and take some questions. If you own an Android phone and you happen to have the Expo app installed, I know, big ask. There's a QR code. I can't see many people reaching for their phones. I will put this back up in a moment. But also, all the code examples from this talk are available on GitHub. So if you want to run any of those GIFs yourself, have a look at, just search for Bile Winters on GitHub. Yeah, sorry. And I'm sure you'll find the code examples. I'm going to flick back to that QR code, leave that up.
Thank you, Paul.